topic here, one of the measurement topics. Alright, we're going to read quickly. The diagram below shows a gold bar in the shape of a trapezoidal prism. Its volume is 2,886 centimeter cube. The length and the height of the prism are indicated on the diagram. Calculate the area of the shaded cross section of the trapezoidal prism. Now, the shaded area is here. All volume measurements is follow this formula. Volume equals area times length, or volume equals area times height. The reason for that is that when you have a shape, if you keep extending the shape, what's happening here? But you see what's happening in the shape? It's getting what? Longer. What's that? Right. So this will be the L in this formula, and the area of this cross-sectional shape. Okay? Likewise, you could see in terms of height as well. Say you have a circle, say you have an Oreo, and you keep packing an Oreo upon an Oreo. What will happen? Yeah, but what shape do you think you'll be forming? Very good, you can start to form a cylinder. So whatever the area is of the circle, times the what? The height. So these are the two formulas we use for volume. They are interchangeable. If the formula already has an H in it, then you use L. If the formula already has an L in it, then you use H. They are the same. Okay, remember length, height, and width is all a matter of orientation. If I take this marker, from here to here is the height. If I turn it like this, that is not the height anymore. That is the length. You understand? The height now is this. So height, length, and width is all a matter of orientation, how you turn it. So now based on that, they gave you the volume. Yes, they gave you the volume, right? They gave you the volume. Let's use positive. Okay, good. So based on this, the volume is 2,886. That's what they say the volume is, or the area? That's the volume. Good. And can you find the length in this diagram here? 31.2. Very good. So this is 31.2. Then what you do? How do you find the area now? Very good. You transpose. Excellent. What's the answer, somebody? Quickly. 92. Right. And guys, remember centimeter squared. Good. Because area is centimeter squared. Excellent. Alright. The cuboid shaped gold bar shown below has the same volume as the trapezoidal prism shaped gold bar displayed. Calculate the height h of the cuboid shaped gold bar. Cuboid shaped gold bar. Calculate the height. The volume is the same. Okay? Volume is the same.
Esdaille is the figure, right?
Huh? Between A and H? Yes. You see, two letters come together is multiplication. How do you find the area?
The value equal length times space to the cross.
Okay. Volume length times width.
Base in base.
You realize that the area is still length times width, about that?
Yes.
And then you had attach on, remember I had one formula on L? You realize the L with the one, the L with the doing one. Huh? Well, they're two different lengths, so they're going to be clashing. So remember I told you, you can use one or the other. If the formula has an L already, use the one that has the H. If the other one has the H already, use the one that has the L. Okay?
Yes.
Like you said that. What's the length?
30.
30.6 times
8.2.
8.2. Work it out quickly. Multiple the knife. Huh? With louder, please. 250. Guys, everybody here put only hear one person.
250.92.
Okay, I want to make sure that it's correct. Let's do that quickly, guys. You won't have food, right? Let me see, other captain going out. You say you got it? You got it? Okay, the problem. The trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. When something is melted down, what aspect is being melted down? What mathematical word would you say is being melted down? When something is being melted down, the shape is being melted down, what is being melted down to be transferred elsewhere? It's a mathematical word. It's a solid. Solid. How do you measure solids? What do the weight of it, yes. But you will say so? The matter, okay, you got the chemistry. The volume. You melt. Okay. So we have here the volume, the new volume based on each sphere will be 481 set in the cube. Very good. So the volume of a square, we have the volume which is 481, 4 over 3, 20 over 7, and R cubed. We are searching for R with the radians. Okay? Based on that, can somebody bring over this over here?
Yes.
Do it for me. So 481 times, flip this. Very good, sir. 21 over 18 gives you R cubed. Yes, 480. Oh, this is the answer. R. 21 times 481 is 10,000, sorry, 101 divided by 88. And then the cube root of 114.8, because that's the quotient from 10,101 divided by 88. Cube root of that gives you 4.9, correct to 1 decimal place. Go. So we have 4. You know, pi is 22 over
7.
7. And we just found R to be what?
4.9, so we're going to substitute it.
4.9 squared. R squared. Quickly, what is all of this combined? Am I the answer? 301.8.
0.8.
Somebody back check for me, please. This is area, centimeter
Squared.
squared.
Correct to 1 decimal point.
The density, again the density The mass, we do not know. But the volume, we have the volume from here already. See that? So, remember I told you, the unit of measurement tells you what is going on up here. Because mass is represented in grams, volume is represented in centimeter cube. So as a result, the volume goes here, 481. You guys remember this triangular thing in trigonometry? Look at this. D going here, where do you think mass going? Huh? On top, everything going here? Volume. So we want mass. If we want mass, see, imagine that? Imagine that?
Yes.
Yeah. So mass is density times volume. So put it here now. Mass is density times volume. What's the density?
90.3.
What's the volume?
481.
Multiply those together.
9,283.
9,283.3.
283.3.
Good. Mass is what? Grams?
Yes.
Thank you. And we'll pause what you think. Now we have May 2023. 2023. Make sure you head up that, please. What question is it?
Question 6.
Question 6. Okay, May 2023, question 6. In this question, take pi to be 22/7. So that is crucial. Pi is 22/7. Sometimes they use pi as what? You remember? The decimal, the decimal. 3.14. But you know that's a short number because pi really is an irrational number. Pi has no end. Pi has no end whatsoever and the number is going to repeat itself. Also remember that pi should not be able to be placed as a decimal, as a fraction. Because irrational numbers are numbers that can be made as rational numbers. But 22/7 is the closest fraction, one of the closest fractions. And there's a fraction that is still closer than this. That you could try to get pi. But also to remind you as well, your calculator is supposed to have pi in it. So if you're going to use, if you're going to work on pi and then they won't state what pi is, then I would advise you to use the pi symbol on your calculators. If not, if they tell you to use 22/7, then don't do that. Actually, write out this stuff and work it out. Alright, so based on that, in this question, take pi to be 22/7 and the volume V of a cone with radius R and height H as this. Now, CXC gives you the formula. That is a blessing. They tell you what the volume is. And as you look in the formula, it has in what? Pi. That has to be substituted with this. You have R squared. You got to figure out which of these is the radius. By the way, which is the radius? Look at there. Right, O to N, which is 7 centimeters, which is stated what? Right here. So let's read here for me now. And what the radius go after 2? 1, 2. Shows a sector O M R N of a circle with center O, radius 12 centimeters, and sector angle 168 degrees, which was formed using a thin sheet of metal. The question asks, calculate the perimeter of the sector above made from the thin sheet of metal. Okay? We're going to calculate the perimeter. The first thing on the docket is, if this is radius, what do you think this is? Radius as well. Good. Right? So, if this is 12, this also will be 12. Okay? This also will be 12. Now, the thing is, you have to find MRN. A perimeter means what? This ain't gonna circle. This is piece of a circumference. I know what you said. If you're gonna have a fence in yard, what are you gonna do? That's as good as well, but what's up this
You
moment?
put a measurement, really.
If you're gonna fence a yard, what are you gonna do?
Measure.
If you're gonna fence a yard, what is the
Length.
perimeter of the yard? Is that the distance all around? Where the limit of your land stops. But that's what perimeter means, distance all around. So you can't even do a perimeter. And you can't tell me why would I say it.
So I can't use whole measurement.
You can't use what?
Whole measurement.
Yeah, but whole measurement of what? The outer skirts.
Okay.
Right. Also in here, you can find the perimeter of the class where you go by the border line and go right around the border. That's perimeter. So distance, perimeter means distance all around. Okay? Now, we have 12 here and 12 here, but we don't have this. What do you call this shape? What kind of line is this bad 12 right? It's not a semicircle. Who can tell why it's not a semicircle?
Carry line in fact.
The diameter should have been straight, but catch what you're saying. Somebody use a word as someone, we would A, 3 letters. Arc. This is what you call the arc. The arc is a part of the circumference. Circumference is the full arc. Once an arc goes right around, that arc represents the circumference. So the only shape that has a different word for perimeter is the circle. The only shape, when you hear perimeter, the only shape that has a different name for perimeter is the circle. The circle we have for the circumference. On a pizza, what would that be on a pizza? This is what you're thinking. If you buy a pizza, what would be the circumference of the pizza? No, because I think. I mean, in the kitchen, the crust. The crust is the outer one, boundary, the outer border, the perimeter of the pizza. And who is that crust? Good. So this is the crust what we want. But in math, it's called, do the symbol, it's a fancy L. It's an L. Fancy L means length of arc. Or as in the formula sheet you recognize, they call it shortly for arc length. What's that? The arc length.
Yeah.
So the arc length is a section of the, we will see, circumference, which is the crust of the pizza. Am I catching me now?
Yeah.
Oh, so we want the whole crust. We got the 8 slices still here. Somebody gonna take out them set of slices over here. So only that part left, and the cake or the pie or the pizza. We only want that section of the crust. Huh?
Is there eat
Yeah, me eat it up. Right? So the arc length is a section of the circumference. Now, what another word for circumference again? Perimeter. Good. So now, how do you find the circumference? I use the big C. So let's find the circumference. What's the circumference of a circle? You understand? Yes. Pi something. Pi is correct, that's squared.
G.
No.
Q.
That's the area. Very good. Pi times the diameter. Pi d. Very good. But there are two. Because in that case, the diameter, we don't have a diameter here. We have 2 radii. So split the diameter into two radii. You can have a pi, instead of 1 diameter, you can have 2 radii, well, radii is plural, right? But we don't write it like that. But we don't write the 2 behind. In algebra, the number always goes before the letters. And this is a letter actually, it's a Greek letter. Like alpha, beta, gamma, sigma, This is called pi. It's a Greek letter. So when they went to the alphabet, they went to the Greek alphabet, okay? So this number must go in front. So all this is correct, the number you write is what? 2 pi r. Remember see that?
Yes.
Good. So always remember, number goes in front of letters. Pi is a letter. Even this is a letter. Remember theta? Remember this is an angle? That's another Greek letter. Theta is also a letter. Good. So 2 pi r is the circumference, or as Yale said, 2 radii is what? Could give you a diameter once they're joined as a straight line. You understand that? But we're not finished yet. We're cooking on gas. That is the circumference. But we're not dealing with just the full circumference. We're dealing with what? We're dealing with which is a section of the circumference, a piece of the cross. You understand? So, if you realize something, since we're dealing with a piece of the cross, it will have the same formula. Let me use pi d first. You'll have pi d theta out of 360, or pi 2r theta, write this for me, out of 360, positive. The difference is, this doesn't have a section. What do you think we're going to here? Who can tell me what number do you think we're going to here? 168 is the section of the slice that we made. So that's what I'm going to do. This is not whole pizza. So this would have been 361. 360 over 360. But 360 over 360 is what? 1. And would 1 change pi d? 1 times pi d will be what? Pi d. And 1 times 2 pi r will still be 2 pi r. That's why we don't put that part on this. Because you have to put 360 over 360, which will still give you 1. So it's a waste of time and penny and marker. But you have to put it on the arc length. Because on the arc length, you only have a section, or in a piece you call that one, a slice. It's a very big slice, eh? Well, depending on how you put it up. Okay? Everybody watching? Yeah, everybody? Let me take it a long time. This is the first question here. We have to start moving, okay? So, the arc length, this is called the arc length. Yes? It's the arc length. There are also pi. So, let's substitute. Let's say use pi as 22 over 7. What is the radius?
12 centimeters.
12
centimeter. And then take that.
and then what's the angle? Quickly guys, what's the angle? 168, so I'm writing over 360.
Is a whole number. Is a
We don't think as a fraction.
Is a whole number.
But once these are fractions, everything is should be as fractions, so let's put them over 1. Remember, every number is a fraction, let's put it over 1 and it becomes fraction. Alright, possible? The answer is 35.2. What was the original question? What?
Perimeter.
Perimeter. But what did we have before? What did we have before? What did we have before? Huh? Wait, what did we have before? What did we have before? Look at the diagram. Look at the diagram, guys. What was given to you? This was given to you. Then we found out that this has to be the same because it's the same radius.
Yes.
And then we just found what?
The
R. So then 35.2 go here. So what's the perimeter? What's the perimeter? What's the perimeter? Perimeter means what?
whole thing. Then we
Oh,
check.
add it up. Add it up.
Add up what?
24 plus
12 and 12 is 24
Plus
plus
35.
35.2. I got to focus. The original question was the perimeter. That changed.
59.2.
Right? We got the distance all what? Around.
59.2.
What? So 12 plus 12 plus 30. Plus
Back up here, Dalton.
35 point 24 plus 35.2, which is what? Which is what? Which is what? 59.2 what? Centimeters. Guys, do not lose track of where we are going, okay? Is made from the sector by joining ON to ON as shown below. Now, as you know, you had a little R. You had your R. I think M was here, right?
Yeah.
And N was here.
Yeah.
And you take your paper and you fold your paper, right? That side now becomes what? Remember that? It now becomes the make it for name, guys. What do you call this? Say it over the camera. Good. So the arc, which the cross, when we say you get the cross, you understand? Now we take it, don't forget your slides, and you fold your slides, right? And make it into a little circle. That circle now comes a circumference. Really, where N is, but N at N. You really touch? Good. So you now move from having an arc, you fold it to form a cone. So M and N now comes a circumference. What was the length of arc? Can I remember?
35.2.
So yeah, the length of arc we had on the arc length. The arc length was 35.2. That now comes the circumference. What's the formula for circumference again? We had a new one. That's what there. Pi d r 2 pi r. Good. And the thing is, they said for this question, calculate what? The radius of the cone. So think which one you're going to use? 2 pi r. So you're looking for what? Radius. So 2, come on, right? Pi r. Good. So guess what? We know the circumference is, the circumference will now be the arc, which is what? Thank you, Joel. 5.2, beautiful. We have the two already. They say use pi as what? 22/7, so make everything into a fraction. And now we're looking for R. We're looking for R. That's easy. I have everything else. So, this is what? 44 over what? Good. So 44 over 7 times R. But what is that the question?
Oh.
2 times 22. Right? Now, whenever a fraction crosses the equal sign and is joined by multiplication of another, listen this carefully. Instead of saying 35.2 divided by 44 over 7, which gives you the divide sign, what happens is that when the fraction crosses the equal sign and you will join by multiplication, you simply flip it. So you put 7 now over 44. Remember that? Normally, if this was a regular number, we'll divide over here by what the number is here, okay? If this was 44 by itself, to find R, we'll say 35.2 divided by 44 equals R. Everybody agree?
Okay.
It's not a regular number, it's a fraction. It is actually 44 over 7. So whenever a fraction crosses the equal sign and it was joined by multiplication of 44 over 7 times R is 44 over 7 R. You understand? It flips. You flip it. Flip it for me. Equals R. Multiply that for me now, please. If you're going to walk over the part. What the answer is? Destiny? 5.6. 5.6. Anything afterwards? You would just straight 5.6. Right, second division. Okay. So what's that? Remember, whenever you divide by a fraction, let me show you why you flip it. If I don't want to show you why I flip it, let me show you why I flip it. 35 as a rating, 35.2 divided by 44 over 7. Let's write that a different here. 35.2 divided by 44 over 7. What can that mean? What can that mean? What can that mean? Quickly. Good. So this is 35.2 times what? Now you see the thing?
Yeah.
You see the point where you split? So instead of going to all this bring my wall, just bring it over, flip, and keep what? The multiplication sign. Normally this sign will change to divide, which will be this. But because we know you're going to change divide to multiply, and the fraction going to upturn, we just simply put times again and flip it, okay? I teach you how to take these, don't waste any exams. Alright? ON is 12. And we said ON is what? 12. So if that's 12 and that's 12, ON and OM has to be 12. We found R to be what? 5 and 6. Can we find the height?
Doesn't that little section is the 5.6? Doesn't that little section is 5.6?
The R. Yeah.
Okay.
That's the new radius there. Think about a hero. These things that jump out at you one time. What shape is formed from O to the center to M? A right angle triangle. From then, something's supposed to jump out at you.
180.
Well, you don't say anything. It can't say anything. A right angle triangle gives you two processes. And I told you one is called a theorem. What is called a theorem, guys? Begin with P. Pythagoras' theorem. I am so many for example. Pythagoras' theorem. Once Mackenzie said a right angle triangle form using either trigonometry with sine, cosine, and tangent, or Pythagoras. Down there though, if you realize something, what? They have not given you any angles. All they gave you is what? That is what? All they give you is what?
Measurement.
The sides, the hypotenuse, and another side. So that's Pythagoras' theorem. What's Pythagoras' theorem? You say A squared, or A squared.
Plus B
Say what is it, man?
A squared plus B squared equals C squared.
Excellent.
Boy, yeah.
A squared. The answer is B squared equals. Sorry. A squared equals B squared plus C squared. Any letter come anyway. So always say it doesn't make a difference, okay? Any letter can go anyway. Okay? I need to remind the class to put H. Why would I use this instead? To remind you that the one on the outside is really the hypotenuse. Excellent. Everybody understand?
Yeah.
So looking at up here, what do you think will go here? What going here?
Good.
Good. How do you know this is the hypotenuse?
Because it's along the side and it's
The side is on the side.
it's the angle.
The right angle. Good. So what going here?
5, 6.
The square root. It can go either here or here, okay? It's your choice. We don't care because
It's still going to be possible.
good. And you're still the transpose to get the right answer. So you have a choice between whether you use the A or use the B. What is 12 squared? What's in the primary school? You know what is 12 squared? Good. So by the 5.6 squared is what? 31.36?
Yeah, because 6, 36 is
36, yeah. What's next?
Transpose.
Repeat it here.
Carry over the 31.
No, no, substitute. Somebody carry away. Carry over.
The 31, 36.
Yeah.
So give me the equation.
This square.
No. This square over here still. That over here.
144 minus 31.
What's the difference of those two?
112.64.
Square root that for me. 10.6. I won't have one. I'll never back that. Yeah, but what other one did I get?
10.60, but you don't have the zero.
10 what?
It's 10.60, so you don't have the zero. 8.
80, okay, good. So let's put that 10.6 there, okay? Alright? Since everything got one decimal place, everything is one decimal place, let's keep it as one decimal place, okay? 10.6 centimeters, no problem. Pause the camera. Now, this question asks, calculate the capacity of the code in meters. Let's quick backtrack. Again, just to backtrack a bit. When we started writing down the triangle, we recognized that only two processes could work, like the trigonometry or Pythagoras. Trigonometry deals with both sides and angles, and Pythagoras only deals with sides. Okay? Now that's backtracking. Let's come back forward now. Calculate the capacity of the code. When you hear something about capacity, what is the capacity of this bottle? What you trying to figure out when you hear capacity?
How much you can hold?
How much you could hold? You know what the V now is volume. You see how the switch up was now? They ask you for the volume, calculate the capacity for how much, what's the volume of the code, how much you could hold. So capacity and volume is very similar. Okay? Is it? Very good. And here what happened, they give you the formula way in the beginning. You are lucky to give the formula because once you go, they never give the formula. You have to remember these things. And that's a lot hard to remember. Yeah, but once you open it over and over, it becomes easy. Give me the formula.
V equals 1 pi r squared.
H. Remember the general formula. So let's go down. We substitute it. A third. When I say use pi as 22 over 7. What was the radius? Anybody remember? Why not 12?
Were you asked what was wrong?
Radius.
The radius?
Yeah. Somebody said 5%. 5% is correct. But why 5.6 and not 12?
Because we're finding the radius of the cone.
The cone. The 12 was the radius of the metal.
Yeah.
Right, it's right. But now, when we make it into a cone, the new radius becomes 5.6. And what is the height of the cone?
10.6.
10.6. We just found it as 10.6 just now. Hey, before you walk on all of this, remember this 5.6 squared, eh? So this is saying 5.6 times 5.6. Okay? Somebody walk on that for me quickly. Walk on this middle one for me quickly.
Which one? 5.6? I'm not doing that. 31.36.
Oh, 31.36. Okay, so what all of this now for me? Let's put everything in the calculator.
348.
Yeah. Somebody back check. No, I get 340. Back check the answer. Mackenzie, do it as well on your phone.
21 is the bottom.
Children are what? Point 2 is it? I don't have point 2 here, but then let's see if somebody get point 2 as well. Pass it.
Excuse.
Good. You see children are 40.2.
CMQ.
CMQ. Why CMQ?
Is
Volume always.
Cube.
Okay? 3 dimensions. Okay, now you need to know this. 1 liter equals 1,000 centimeter cube. But guess what? When we say it's 1,000 here, any reach half, and half of this will be what?
Boy.
Good. So 80 is even less than half of this. So it's less than 0.5 liters. How do you convert this into liters? Divide by 1,000. Do this one. 1, 2, 3. 0.3482 liters. So what did we do? We divide 348.2 by 1,000. I think we know there's 4.3 spaces.
That's what you got, is it?
In this question, use slide 20/7. The diagram below shows a scale drawing of a running track. It consists of a rectangle and 2 semicircles with the diameter Ln and MP. Ln and MP is both 49. So over here is also 49 meters. Good. And say LM and NP are both 98 meters. First question says show that the total length of the running track is 350 meters. The whole thing is 350 meters. What do we have to do? Right? We don't know from here to here is what? And then from here to here is also 98. But what do you call L to N? What do you call that? The name for that?
Length.
Length of R. Or short one is what? R. Length. What does it mean? So the R length, we need to work out. What's the formula for R length again? Let me see you remember. By it could be 2 by R e to over 360.
Poidi.
Which one do you think is better?
Poidi.
Tell me why.
Because it's easier.
No, that's the reason why. It don't matter the diameter. So clearly, This is the better one to use because the diameter is given. If you use this one, you're going to cut the diameter from 49 to what? Half.
And put it is 22/7.
Very good. So let's substitute now. Let's move quickly.
22/7
22/7
times
times
49.
49 over 1. What is the angle?
No.
You're going good, huh? That's 90. And diameter is what?
90.
That's 90.
Well,
Look at this. Tell them what is half. You have a semicircle. When you call a straight line,
really?
180
80.
degrees, half, good, half of 360. So what Javier said, instead of putting 180 for 360, you're going to reduce the factor to its lowest number, put what? You're going to simply put a half. Then you have. Make it work easy in exams. Half of 360 is 180, only is half. And I say that's semi one. Good. Semicircle means from the diameter that will be 180 degrees. Okay? Good. Somebody want to calculate that quickly for me? 22 times 49 and divided by 7 times 2, which is 14. Say 3? 77. Good. Now, question. Look at the diagram. How much arc lengths do we have? So we have this arc length, which is L to N, and we have P to N. So how do you find the distance all around?
7 times 2.
Very good. So, yes, good. The perimeter of the thing is what? 2 times the arc length plus 2 times the what? The 98. Very good. Excellent. So the arc length was what? 77? 2 times 98. Whatever that is. Somebody go quickly. Oh here? Oh here? 196? And what is it?
154.
So what's the perimeter? I'll show you the perimeter again.
350.
And that's what we're supposed to find. Remember what I said? They don't tell you 350, you know? So you're just basically confirming that everything gives you. Yeah, they don't tell you the perimeter is 350. So they will like this copy answer, you're gonna you want to see your process. Okay? Remember, it's 2 arc lengths, 2 arc lengths, and 2 horizontal lines. Positive. This is saying meter, this is saying per second. If I write this a different way, look at this. Meters, seconds. What do we measure in meters? Length. I'll put distance. Okay, you're correct. What do we measure in seconds? What's that? This is this. That means, he said, Data walks at a constant rate. So if I walk till I run, till I sprint, what do you call that? You know what for that? I feel like another one. Speed. That is actually the formula for speed. But we have an average speed. That's short of average. You mean when we put average is because nobody starts at 60 miles per hour. You have to what? Build up. You have to accelerate. Accelerate means just starts nothing. You build up. Right? So when you hear somebody was going 40 miles per hour, the one that naturally going 40 miles per hour, their peak speed was 40. And when they start to slow down, they're going to slow down till they reach what? 0. You understand? So you have to talk about what? Average what? Speed. Average speed. So when Javier starts to run, Javier will start exactly 40. Gone 40. He has to do what?
Gradually go.
Gradually come up, build up. You understand? So don't ever forget our base one. Average. We want to know what was his speed after he built up and then you start, okay? Good. So what we have distance and time, you ever see that? So this is a new formula you learn. You might have seen it before, especially in blue physics. Speed is what? Distance over time. Now they gave you his speed. What was his speed?
1.4.
1.4 meters per second. What's the distance?
7.
Really? You think this question connected to what above?
No, it's
Oh,
really.
yeah.
You go on.
In the same track?
Yeah.
So what is the distance of a lap?
350.
Thank you. You see, so that gets higher?
That's what the question asked. I
You're gonna find
can't,
out now.
I can't see. So.
It's 10. That's what.
Well, the question asks for, you see, it's already, the dog like little, yeah, calculate the time it will take him to walk 7 laps around the track. But before you reach 7 laps, you have to find out how long it takes to go around what? A lap.
Yeah.
So we put T for sharp for time, okay? What's that? Good. Can you follow what the time is?
Yeah.
Tell me.
Well, just multiply.
You said multiply, no.
Yeah, I'm sorry, was it?
Remember this sine cosine, remember sine equals, sine is what? Opposite over hypotenuse, remember that?
Yeah.
Remember this here? Let's take out these and follow this. What is on the left side? What's on the left side? Speed. Okay? Let me put S for this. So S dt. Speed. What is on top?
D.
And what's below here? T. If I want to find the distance is what? Speed times time. You understand that? Am I watching?
Yes.
If I want to find time is what?
This one is.
So this is what here. So it's speed. The distance to find it. Size.
The distance divided by speed.
Right.
Right, so time is distance divided by speed. What's the distance again?
350.
350. What was the speed? The average speed was 1.4. What was the average?
4.
What's the answer? What's the time?
Can't bring it up.
Gotta go waste the time. Let's go.
That's 250 seconds, I guess.
250 seconds. Excellent. 250 seconds. 36 seconds. How can you done that for me? Pass it up. I can't see you not waiting here. You serious?
You said pause it, you didn't tell me to stop it, but.
So here. Okay, so let me go. One way to go. Calculate the time it will take him. Oh, yeah, wait up. If I remember that, the part that complete in 1 hour will let the same speed. Why is it possible, by the way?
If 60 seconds is 1 minute. And 60
Okay, I want to come up with it. The minute we fish reading.
Elon.
I should have named it.
It's on. And then it's on.
What's that? Let's go. 7. So it was said to be done in 7 laps. All of this is just 1 lap. The 250 was here, right?
Mm-mm.
No, that was last thing, right?
Mm-hmm.
So when we make that is there.
You know that one.
Let's go to this quickly. 60 seconds equals 1 minute. 60 minutes equals 1 hour. So 1 hour is 60 times 60. A quick way to multiply this is that you bring them into zeros. This is what you do. When you multiply anything with zeros, you bring them at 0. Then 6 times 0 is 0 still. You simply put the 0 there. And 6 times 6 is 3600. So if 3600 seconds is in 1 lap and he runs 68 seconds, and Mackenzie said you divide both, you get 52.9 laps. The thing is though, the person have not completed 53 laps. So I will be telling you to be careful, you can't round up certain things. You say, well, you can have a half of an apple. Like, for example, you can have a apple, sorry, let's do one. So you can have a half of a bell. Because a half of a bell can't use. Why would you agree? If the bell matches and break in two, could you weigh the bell still?
No.
No, so you wouldn't count that as a bell, right? So you wouldn't say 52.9 bell. And the 0.9 doesn't serve the purpose, because you can't weigh a 0.9 bell. Everybody understand? The same thing with time too. He ain't complete the lap. So I would say he completed 52 laps, and it is possible if by strength, if he wanted a little faster, he could reach 53. But for now, he only completed what? 52 laps. This happens at also in running and in long jump. Okay? You don't round time up. You leave the time how it is. Or the distance. So the man ain't reach 24 feet, the guy say really close to make it 24 feet. No, he ain't reach it. Okay? Nathan completes running 1 lap of the track every one. Good, Destiny, let's go. Tafari and Nathan starts running at the same time for point L on the track. Each completed a number of laps of the track. Calculate the least number of laps that each will complete before they are both at point L again at the same time. It's a very simple process. Let me give you this. Okay. Because remember, you deal with LCM. That was 68 and 72. But these numbers will get bigger and bigger. 68 and 68 is what? 68. You put, I don't know. 68 was what? 1. What next number was? This was 72, 140, 4. The next one was what? 2 or something?
24.
20. 8 to 16 or something like that?
216, yeah.
Yeah, and then you continue. This was what? 16? What else?
136.
136,
204.
204, and then continue it. Actually, see, when they don't meet up again, when everybody knows common multiple they meet, right? When they keep going and keep going, right? They are saying here that a quicker way to do this is you put 68 and 72 in something we call division. This is what I call the division method for prime numbers. Yeah. Right. You start with the lowest prime number. Give me the prime numbers.
2,
2,
3,
3,
7.
5,
Okay.
7. What's the next one? 9.
13.
No, you have a point number. Good. Javier, the next point number?
No, 11.
11. Then 13. Okay. I'm not focusing here. The only even number, or the only even number that is a prime number is what? 2. And that's the smallest one. So it's starting 2. 2 to 68. After 68, 34, or I will screen up. After 32 is 36. Can 2 work again? They're more even numbers, so 2 can work again, okay? After 32, 34.
17.
After 36, good. Can 2 go into 17? No, right? So you leave it.
Where's G?
2 can go to 18 though.
Yeah.
9.
And then
You got up to 3, that's the next number. 3 can go to 17 still. 3 can go to 91. So you bring them down. 3 again.
Yeah, it's 17. We do what?
1.
Next one.
Good. Next one is what?
17.
17 is a prime number, so you have to go jump when you do 17, okay? 77 goes 1. That 1 come back down. So you have these. Alright? You have these now. Let's go. 2, what 2 have? What 2 have? 3 there, right? Then 3 times 3 times 17. Okay? That should give you see?
8 days, 17.
Right, so this gives us what, 1,000?
224. Yeah. Yeah.
1,200 and
24.
that's not 1,224, that's 12,201. 45. And then you divide both numbers.
Yeah, man.
But what are seconds?
Yeah.
Wait a minute. And that was at 5.
No.
Oh, okay, good. So now you see,
And then you divide that by 68 and 72.
right, so you see how long 68 each? 1,224, 1,224. That would be what? The LCM, right? Let's see how long 68 reaching. So 1224 divided by 68, which is what? The power, right? Gives you what? 18 laps. And Nathan, 1224 divided by 72 gives you what?
17 laps.
17 laps. Now it is proper place. Why? Because he can run more laps than he if he run it quicker. So the LCM is actually better when you do. The other method we did, we had to switch over the numbers. But now, we say no switching over the numbers. The power right, you got the 18 laps and he was running quicker, so you have a couple more laps. And that data. God bless you today, guys. Thank you for coming. Have a wonderful day. It's moving. Alright, okay, so last time I told you about this probably being the area. I looked it up and it's not the area of a cone. Okay, so scratch that from your record. This is the volume of a cone. But this area is not the area. Generally the area goes there, but that's not what the numbers are going for a cone. Okay? So that we'll move off of that now. Now we are going to be doing January 2024. Do January 2024. And we have can we share it with you? The diagrams below, let's read them together like together. The diagrams below show a spherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12 centimeters. Good. The height is 17 centimeters and the radius of the bowl is R. Show that the volume of the cylindrical tin is 1,923 centimeters cubed, correct to 4 centimeters cubed. Okay, so we're going with this. Remember in January 2024, January 2025. Okay, question 6. First of all, the volume. What shape is that, by the way?
Which one?
The second one.
Cylindrical tin.
Right, cylinder. Is that a cylinder? Is that a cylinder? Okay, good. That was cylinder. Whoop. First of all, you shouldn't even be asking me if I have any question, you should know that is this referring to. Because I said find the volume of cylindrical tin, so when you ask me which shape you're talking about, only one cylinder. Okay? The diameter is 12 cm.
Yeah.
The height is 17 cm. What's the volume of a cylinder? As my tell me. Oh no, that. The formula.
The square where H.
R square
H.
H. So this would be L as well. L or H. Good. In this case, it's the H. Okay? Where pi r square is the area of the circle and the H is the extension. Okay? So it applies more to these, like these prisms and cylinders and cuboid, but the other one that can have, the cone is a kind of unusual shape. Okay? So it would be very hard to figure out that one based on the area. But anyway, this is the area here, that's the height. Now, let's finish some stuff. Let's say use pi as what? So 22 over 7, the radius is what? Think good.
6.
Why is it 56? Excellent, this is the diameter. So you should know that 12 divided by 2 gives you 6. Same. So we have 6 over 1 squared. That's the height.
17 over 1.
Good.
No. 13, 46, 4.
It's no looking at the calculator. You know, 6 times 6 is 36, obviously.
1, 3, 4, 6, 4.
1. What is that?
What do you want to say?
13,462.
4 over 7.
So how can we get this?
Wait, what?
And this is the answer.
You're gonna divide by 7 is over 7.
Oh?
Yeah, you want to say something?
I said divide by 7. Oh, okay. I thought I had given you one, the full answer. Okay, good, okay. Like the stages, that's no problem. What's the answer now?
1,923.42
Huh?
round that out to 3.
Okay, good. But it says up to what? 4?
Significant failure.
Good. So 1, 2, 3, 4. 1,923. Correct. 2, 4 significant figures. But you have the whole because the bowl is completely filled with soup. Let the bowl we have up here. Okay? This bowl here. We're going to completely fill it with soup. Then what we're going to do, we're going to take that bowl and we're going to pour it over into the cylinder. So, this bowl,
Can I back up to the board, please?
huh?
Exactly. Can I back up to the board?
The bowl,
What are we, please?
this bowl will be poured out into this. But when you pour it into this, they say you know it's going to cover how much?
90%.
90%. Right? You're only covering 90% of the cylindrical tip, so it doesn't pull it up. Okay? So remember that. The bowl does not fill up the cylindrical thing. It only goes to 90%. But based on that, we already know the volume of the tin.
90% of 90.
So then what do you do? Find what?
90% of
90%.
So 1923.
Find 90% of
17,
the
30%.
cylindrical tin. So 90 over 100, is that right, guys? Or what's the cylindrical tin? What's the value of it?
Oh my God,
Good. 1,923 over 1.
17, 30.
So you end up with 1,700.
30.7.
0.7
Yeah. Centimeter cube.
70 meter
Cube.
cube. So you already find 90%.
Mm-hmm.
So that's how easy that was, like, the cylindrical, the tin could hold more than the bowl. Right? So the tin could hold 1923, 90% of that will be this. Okay? Now, what's the volume? They gave you a volume. Calculate please.
The value of the sphere.
Yeah.
Yeah.
B equals
4 over 3 pi r
cube.
cube. Oh, okay, good. You have a problem? And we could tell you the problem. Look at that formula and look at the bowl. What shape that bowl comes from? A sphere. So that is half of a sphere. Half of a power. basketball or football or volleyball, whichever, it's half. You understand that? If this is the formula, for our volume of a sphere. What do you think you should do to this? You're gonna cut it in half. Excellent. So what you do, you put V equals a half times 4/3 pi r cubed. Now I want you to think of that in exams. Because that's a trick. They gave you the volume of a sphere, but that is half of a sphere there. And some of you went to the exam to simply use this and not do what Ian said, cut the formula in half. I'm going to have to do this fraction here, tell me. Half of 4/3. Guys, it's a simple multiplication.
So what? Yeah.
4/1. Break down that.
2/3.
So this breakdown to 2/3 pi r cubed. You see that? You can't have nothing else. Everything you join by multiplication. Once something you join by multiplication, you have whichever one you want. Okay? So we have the natural one that is we have the 4/3, which we get this. So this is your new volume formula. What does this represent? Who will tell me? The volume of the bowl, which is a half of a sphere. Excellent. Half of a sphere. We write that number. Half of a sphere. Or as I said, volume of the bowl. Okay, good. So now we go back to the question. Calculate the radius of the bowl. Okay, so we want the radius of the bowl. We want that radius here. Okay?
To find
So we have to find
So cute.
Kenzie, you're awesome. Let's bring back this over here. 2/3 pi r cubed. Let's substitute. We put back the 2/3. What is pi?
22%.
Good. Doesn't change. It's 22%. And we don't know what this is, so we move on. Because somebody fix that for me.
Yeah.
Let's multiply the top and the bottom. The top will give you 44/21 r cubed. But in the same way, when you have a fraction to cross the equal sign, you need to remember.
What does it about what?
I told you last class, you flip it and keep an operation.
Multiplication.
What is happening here? You're correct. What is happening here? This is what? This is times that. So normally when this multiplication goes over, it comes to divide. But when it comes on fraction, because divide is here already. When it goes over, it flips and keeps the multiplication. So it will be V times 21 over 44 equals what? R cubed. We don't forget to do something, what do we forget to do? What we trying to do with V all the time? What we forget to do? Look above. Yeah, we found the 90% of the cylindrical thing, which is the value of the ball. Right? So we were supposed to put in value 1730.7. Substitute 1730.7. And that's what we found in the first place, isn't it, sir?
Wait, what?
Good.
Just waiting.
1730.7 over
One.
1. Can you tell them? We flip it, and the bracket represents what class?
Multiplication.
Multiplication. Good. So we could do now, you multiply the top, and then we get the product of that if you want to follow. Give me that quickly.
What I mean?
17, 30.7.
One thing.
And 6,000, huh?
344.7.
Over 44.
Over
44.
44.
Yo.
8,108.
Point 20. Point 01. And then you know, what's the average of cubing? Average of squaring is square root. Average of cubing is cube root.
Then me had the whole time and I tried to figure out, should I say? It's so long.
Yeah, it's so wrong in
Yeah,
there.
you have cube root, square root, fourth root, fifth root, sixth root.
No.
That's the answer.
9.38.
9.38. Don't forget about 38. Number with the decimal point, you count it individually. So individual is radius, so you don't have to add on the square and cube. Okay? 9.38, I just said 9.41 decimal place. Altitude significant units. This is 9 point.
Go down.
Correct. Two significant units. Stop it. Right, so the last one, the trick was behind the last one was that you had to find 90% of the value of the thing, because the bowl is only, the bowl's volume only comes to 90% of the thing. So the 90% will be crucial. And good thing about it, they gave you the volume of the thing in the first place. And that's why the 90% of that. Also, the formula for the sphere had to change because they didn't have a sphere. We didn't have a full sphere. We had a table. So the formula had to be half. In this case though, in the diagram below, points L, M, and N are on the circumference of a semicircle with center O and radius of 18 centimeters. Now based on that, let's calculate the total area of the shaded section in the diagram. Well, how would we get to these shaded sections here? What other shape is inside the semicircle? What triangle do you see? Well, actually, it's 3. 1, 2, and then you make one next 3. But I got it, so it's 2. This one here, this one, the 20 combines is formed another triangle.
Oh, okay.
The outer triangle counts as one as well, yeah. Right? Good. So then, we have to find the area of the triangle and do what with it?
Legit.
Huh?
Nothing.
We have to calculate the total area of the shaded section. So which section we don't want? We don't want the triangle at all.
No, but we still gotta find out the length of the outside thing to find the shaded.
Right. So the area of the semicircle. Remember, what's the area of a circle? Okay. The area of a circle is what? Pi r squared. But is that a circle? Similar to the previous question, that's not a circle. That's a semicircle. So the area of a circle is pi r squared. That's the one you should blur it out. The area, what's the area? The area of a sector This sector would be semi what? Say guys, semi what? This sector is a semicircle. What's the area of a sector? What's the area of a sector, class?
Oh, half.
Very good. In this case, you put S for second. Half. May help you. Pi out.
Okay, yeah.
That's what,
Yeah, after the if the area of a circle is pi r squared, 70 is what? Half. So you can't use the full formula, you have to use half of it. Or what you do, you go find the area of the circle and then cut it in one, 2, or half. Okay, understand? Good. So the formula we're using is this. This is derived from the full circle. We don't have a full circle, we have a semicircle. So this question shows us how we have to know to alter our formulas. The last time we got the volume of a sphere, and then we have to find half of it. Now they're asking you for the area of a semicircle, and we know the area of a circle to be pi r squared. So the area of this sector, that is a semicircle, will be half pi r squared. Imagine that? Another way you could have done it, remember this? Remember the area of a sector is also pi r squared 1. Theta over 360. And a semicircle. What do you think I'm going here?
180.
Huh?
180 shade.
180, very good. And 180 into 360. So all we did is put the half one in front. Same thing. But the easier way was you get semicircle, so whatever the area was, put it in half. Okay? Now let's go down. Let's go. That's the area of a sector. What's the area of a triangle?
this,
Half
Please,
base times height. There are a number of formulas, and there's something called half A beside C, but there's no angle given here.
Never said that.
Right, so you need to learn that because W6 when we have a question, that's for trigonometry. Yeah, but they didn't give an angle, so you have to stick with this. There's one called Heron's formula. If they give you all 3 sides, like side this, side that, and side that, all 3 sides are given to you. If that is happened, then the Heron's formula, you use that one to find the area. But we were given base and we were given height. How do we know? What is down here? What did I say?
36, I think. Well, this radius is 18.
So 18 is here.
Yeah.
What is here? 18. Combine, give you what is it? 36, good.
Yeah.
And what is this? They call it O to M.
That's by
That's the height, but based on the semicircle, what is it?
18.
18.
What's the way you call it?
Radius.
It's still the radius. And then these two combine to give you 36. Okay? So the area of the triangle is what? Half? Half of what?
Half the base times
What is the base?
36.
Half of 36 times 18. Half of 36 is what? 18. 18 times 18. Quickly.
So 18.
324.
324, yeah.
I'm going back. I'll put it on a calculator.
No, that was
Oh, this is video tape.
Good. And if the area triangle is that, You know, half over here.
22%.
The ain't change. All the people there, they give the 2%, they ain't change. And this R,
18.
square. I want you to know, when you're squaring a fraction like this, you know you have to square the top and square the bottom, right?
So yeah, I just like put it as
Let's put 18.
34, 30. But
No,
maybe
18
about
is 18 is
300,
34.
I mean 334.
Good,
Yeah.
you put it
Yeah,
at
I just put it one time.
Yeah,
yeah, you put it at that. 22 over 7, y. 334 over 1 times 1
One.
is 1.
And
Because
then 33.
it's got calculators, guys, calculators, so I don't put them down.
You should get 183.
7,123.
7,000.
I'm going as the 22 times the 370.
We need further answers, we need further answers.
Okay.
180.
We start over,
185.
no, but I didn't know the book.
Wait.
Where else spoke up this year?
What?
Where else? No,
When you
really.
got 5 as the first number?
Yeah.
Yeah, 509.
509, go ahead. You don't say something about this now. 509 what? Point.
0.1 centimeter square.
Oh, I forgot about that 2 there. I just said
I was giving you the full answer.
But you say we'll give you what?
Okay, actual answer.
We can't be one something and this is from that.
I
You didn't say one something.
Listen.
It's me say 7 something because it was going through.
Okay, cool.
But
So then we take away the area of the semicircle. We take away what? The area of what? What are here? Of the triangle. 509.1 take away
310.
gives you 100.
85.
40.
40.
1 4.
1 4, sorry, yeah.
Centimeter.
I thought you.
With that, I number.
Thank you.
Like this is centimeter square, centimeter square, centimeter. Everybody catch this? Anything was difficult?
Yeah.
Just. But this is one of the short questions though. Yes. They gave us again pi equals to 207. They keep giving us that. Normally they could give that or 3.14 or 3.142. Remember pi is that cannot be really placed as a fraction. It's one of the closest fractions to pi. Because pi is really an irrational number. But anyway, they keep giving us that. So you have to use it. You have to use what they give you. A piece of wire 61 centimeters long is bent to form a sector. As shown, a sector, another name for sector is slice. If you deal with pizza or cake, you say a slice of cake or slice of pizza. It's bent to form a sector, as shown in the diagram below. The sector of the circle OPQ has sector O and a radius of what? 18 centimeters. Earlier I established this is 18 and O to Q is radius. O to Q will be also what? O to Q will also be what? 18 as well, because it's also radius. P to Q is called what? We had that last class.
Circumference.
It's that that's the full circumference. Circumference is used to the whole circle. What do you call it? This is a section.
Oh, the arc.
The arc what? Length. Or length of arc. But shall we say what? Arc, length. Come on, check the formula sheet to see if that is in the formula sheet.
What?
You might see it in a fancy area. Check the formula sheet quickly.
Did I get him?
It's on the paper I gave you.
Meaning in the exam, did I get him?
Yeah, you have to scroll up and see the formula sheet, but maybe I'm always right. Not gonna write it down.
No, I was asking, like, I never.
Yeah.
Like,
It's in the front of the page. Arc length is given to you.
Yeah.
This
Let's see.
yo.
is
Give me.
yes.
yes. It is area. See, in the area of the triangle, which we just did. So the area is like a half inch. So like, see, you know, what I'm looking?
Yeah.
And so the Heron's formula. This is Heron's formula, right? Up. Well, okay, see what y'all these here? Yeah, what you? Athletes, see here?
Oh.
2 point R, or it could be point D as well. Once you see 2 point R, it could be point D. Theta over 360. I don't want to put it in the back, they put it to the front in the problem. Okay? You got the area of the circle, so you see area of a sector to the middle, the area of a trapezium, we have a regularity. We had the area of a cylinder, the volume of a cylinder, that's what I got it there. Pi R squared AH, we just had that. Alright, the cone here. Who tell us the cone? No, they gave the cone. But the good thing for the cone, they gave you within the question anyway. Okay? No.
No, prism is like
After
No, those are not prisms.
like a diagonal, one of them diagonal.
Isn't that pyramid?
No, because a prism will have prism will keep the shape going through. A cone is having a circle, but the bottom of the cone is a point, an apex.
So that can be a pyramid.
It close to a pyramid, yeah. They remember a triangle. Okay, I'll show you something. Okay, let's come in this. But remember that's that now, because I can't get another one. Okay, see this. You know that's it. Can you think fast? Okay, we get. Alright, good. So 18 arc length. Show the value of x is approximately 80 degrees. We just found the area of a sector up there. What is the area of a sector? We missed something in the question. Read the question again from you guys. Read that question. We missed something.
That's why it's 61 centimeters.
Very good. Stop there. The piece of wire is 61 centimeters long. Back. What would that represent? A word you're looking for. A perimeter. Very good. Which one of these is the closest to perimeter? If O to P, P to Q, and Q to O is 61, as we said, that's the one, the perimeter. We don't have 18 here. We don't have 18 here. And we don't have the full thing. What do you think you're going to do?
Like 18 and subtract 60.
Very good. 61, take away 18 plus 8. Is that right? 18 plus 18 is what? Good. So 61, take away 36 is what? 25. So we just found, is 25 is what? The arc length. And that's the only thing that was missing. Okay? P to Q was missing. So now we have this. After this we finish, you know, we're done. Okay, I said that? Good. So the whole thing is 61, so that means subtract. Now, based on that, since you find the arc length, and the arc length is 61, can we substitute to find what the missing angle is? Because this x represents what? The missing one. Angle. So now, 25 is the arc length, so it equals, this 25 equals all of that. So 25 equals 2, 22 over 7, what's the radius? 18, and Peter over 360. Work out this part for me guys quickly. Let's put everything in the calculator. 2 times 22 times 18, that cut up divided by 7. Quickly. Everybody do it, everybody do it. 113, is it? I don't know how to do the book. 113, is it? You said I put it, you see? No, I can't do it. You got to do the top first. Do the top first. Do 2 times 22 times 18. What do you get for that? 2 times 22, which is 44 times 18 is what? Why? 792 divided by 7. 113.
I mean 1 4.
Is the exact same video? Okay. The problem, okay, let me tell you what. The problem is that I showed you 792 divided by 7, but I never went straight to the answer. Alright? So, that times pi 360 degrees, this is 25 over here. What's next? Tell me what next to do, quickly. What is going next? That's okay. We have this times this. This is missing, this is given. Removing this. When this come over here, what happens? Huh? Why? So you do what? No, this is attached by multiplication. Divide this. Equal theta over 360. What does that give you? The 0.2 flat? 0.2209. One up and 0. Is 0 here?
Sorry. Yeah, bro. I didn't believe it.
Okay. What happened to that? A 6? So it's going to be 0.221 then, okay? And now, internet mapping, this will divide by 360. What's going to divide? Multiply. So this is 0.221 times 360. You know what angle you get? 79.5. 555. So 79.5 or 80 degrees. Okay? I got it. Yeah, 79.54. Correct. 80 degrees if you round off to nearest whole number. Nearest whole number. Okay, but that quickly. So it's, oh, it says show the value of x is approximately 80. Okay, so they give you the already. I didn't even realize that. I didn't even read the plan. But that, is it 80. Calculate the area enclosed by the wire. Calculate the area enclosed by the wire. What did I ask you for?
Area inside.
Yes, what do you call that? What formula do you call that?
Area sector.
The area of a sector. See that now, guys? See, I tell you the name. When you tell to find the crust of the pizza, you get it what? Length of arc, or we call what? Arc length. But we're dealing with the whole slice. That's the area of the Mackenzie, area of the sector. Say it to me, area of the sector.
Area of the sector.
Right, Jenny? Okay, good. So, what's the area of the sector?
If I ask you,
I don't know, you can't get the morning.
yeah, if I ask you,
It's a show you how you're writing and not paying attention to what you're writing. The area of the sector is right at the morning. Let me write it back again. Pi r squared theta over 360. What is pi? What is the radius?
18.
In this case, it will be 18 what? 18 squared. It's another way to write it. That's for those who don't know the x squared. Instead of saying r squared, you could say 18 times 18. That's what r squared is, right? Good. And what is theta now? 80 degrees. 79.54 or let's use the 80 that they give us. 80 over 360 over here, one voice. Good. You're done now. Guys, give me the numerator. But you do 18 and 18 and 18 quickly, quick additions. That's it, that's all. 570,240. Javier, give me that 7 times 360. Let's go.
You go to the first one there.
7 times 360. Yeah, 570,240. That's good, they have to do. And then, what do we do from there?
We can do 226.
226.
28, 28, 5.
Good, so 3 centimeter. This is what area? You said 2 5, right? Well, it's 5 over 2 3. Well, it's 3, yes. That's the answer. Okay? This is the area of a sector. Okay. A cylindrical block of cheese has a radius of 12 centimeters and a height of 8 centimeters. Radius of 12, height of 8. The cheese is divided into equal slices. Let me tell you how much slices for now. We're dealing with this slice. The uniform cross section of a slice of the cheese is a sector whose angle is 80 degrees. So I guess all the slices they're going to make have to be this big, 80 degrees in terms of the angle. I'll show you the diagram below. Calculate the length of arc AB. Again, let me hear what's the formula for the length of arc or the arc length. Let me hear I say for me, please. What's the formula? Yeah. Very good. length of R, 2 pi R, that was a section,
Yeah.
the cross, so what?
Theater.
Theta over
360.
360, very good. Length, let me put arc in it. Arc, length, okay, what's that? What's the substitution? Somebody help me out here.
For theta?
What, the substitute,
Two, trying over
so
seven.
they calculate the length of the arc of AD. You're going to find AD here. Go ahead, sir.
2, pi is 22 over 7.
22 over 7,
Radius is what? 18.
18, yeah.
18,
Oh,
18 over 1, let's put 18.
yeah.
How many, using calculator, you could do this.
Then 18
Over,
over 3.
if you don't have a calculator exams, you should recognize that 18 is going to 36, eh? If you don't have a calculator exams, you should recognize that 18 is going to 36.
Yeah.
How much times?
And 20.
Well, it's now be 1 over 20. Okay, but you have calculators, so we will put that. So let's go. What does all this give you?
The whole answer.
Well, 2 times 22 times 18 times 18, you product of those, divided by 7 times 360, the whole thing.
It's not 12.
Yeah.
12 is 18.
Oh,
Oh,
that's
yeah, it's 12. Yeah. It's 12.
it's 12, isn't it?
Yeah.
Yeah, this is going to be 12.
Wow.
The
Yeah,
radius is
yeah.
12. Right.
I know that's something.
Good call, good recognition.
9,504.
That's why I have 9,500 divided by what?
1820. Sorry. 1,820.
1820, right?
Yeah.
Wait. The 7 times 360, right?
Yeah, make it a letter.
We get 2,523.
Guys, back to what I put in our calculator. And this is finding at 2,520. So what do you get 18? Where do you?
Oh, I just gave this no sauce of this. Yeah.
Right, when the exam, back check your stuff, eh? Please. This is frightening, okay? What's the answer? They're going to take off Chinese. Or one you get two, you know, you manage. What's this? I'll look at back to thing. Let's go. Don't get caught up writing up questions to the point that people answering, you ain't get a chance to answer. The point of this is for you to try to answer.
3.77.
Very good. 3.77. Okay, let me see. 2 more decimal places. 3 significant figures. So that's it. Okay? So then what I ask the next one, that's the arc length. It's a determine the area of the curve face, ABCD. You want the area of ABCD. If I have a paper curve, everybody watching? Either it's not straight. If I tell you find the area for this page, what will you do? The area for this page is what? Length and width, right? So even if it's curved like that, the length didn't change anything. Think about it. This is still what? The width. So the width didn't change. This is still what? The length. So even if I curve it like that, that is still, from here to here, that's still going to say width. How this is good. Imagine. So based on that, he's correct. And he says length times what? Width. Times the length of R. So AB, we just found AB. This is AB. So length, separating, times width, or L times W. The length will be 3.77. What's the width? Based on that. Very good. This is the height, but in our case, it will be width. Okay, understand? Remember the fact that they actually call the shorter side width and the longer side length. Alright, so you can switch it over if you want. Okay? And in this case, the height is down the length. Good. Remember, if I take a marker and I put it down, this is the height. When I put it down this way, it now comes the length. The height of the marker is now the length. Okay? If I turn it that way, that comes the length now from end to end. So everything is all a matter of orientation. Height, width, and length is a matter of orientation. What is 8 times 3.77? 30.16. What is it? Centimeter square, okay? And then ask you for what? Because I was going to find like already the area of the curve face. So area, this is area. Okay? I think it's the last question now.
Yes, yeah, that will be four.
Give me let's go, let's put together.
The
Area of OAB
is 22.6
centimeters squared. That is the volume of the entire block of cheese. It's what OAB is. OAB. The area for this and the area for that, and the volume is there. Give me the area of that, of OAB. Okay, yes, the area. So, if this slice here, the area for up here is 22.6 centimeters squared. Remember I told you for volume is equal to what? Area times what? What? Wait, it could be height or V equals area times what? L or length. Whichever one the formula for the area doesn't have in, they use whichever one. So this is the area and then it extends. For example, the same thing with a wedge. As it extends, so that the original shape is this, right? Would you agree? And then what happens? It gets what? Longer. So the cheese original shape was this slice and it got what? Longer. So area is 22.6 and the height is what? 8. What's the volume of this whole cheddar cheese slice? Start waiting for you to walk out things, what it does. 180, everybody. 180.8 what? Centimeter cube. What's that? So the volume is area times height, which is 22.6 times 8 equals 180.8 centimeters cubic. That's part 1, so the probably got part 2. Small one. So we're going This part two. Yeah, the part one tree. You tell me the area.
You just said,
Yeah.
Oh, that's that.
that's the, I think that's the question.
Oh. Yeah, that's the question. Oh. So you guys can double up there. Oh, sorry. Goes on. In conclusion, this is just a slice of the cake. As you can tell, if the slice continues, if the cake continues on, okay, the cake goes around, okay? However, the cake continues around, okay? This would be 18 as well. This would be 18 as well. Till you form 360 degrees. So, although we found the volume for a slice. There are many other slices going around. Okay? Many other slices going around. How much of these 18 do you need to have to make 360? Well, 360 degrees divided by 18 degrees gives you 20. You need 20 of those. So if you need 20 of those, you take this 180.8 centimeter cube times 20. We know 0 to 8, 16, 31, 0, 0 plus 1 is 1, 28 is 16, 31, 31 is 2 plus 1 is 3. 1 decimal place. So the entire cake will be the volumes of it. The volume for the entire cake will be 3,616 centimeter cube. Right, but the entire block of cheese, a cake, the entire block, I keep eating cake, the entire block of cheese. Alright? 20 came from the fact that we need to have 18 going around, all around. What of these 18 degrees you need 20 of them. Well, then one slice is already